This slide contains pictures of the 12 basic functions. You have to be able to graph all of these functions with shifting and answer questions about their domain, range, continuity, boundedness. There's actually no new information in this entire section except that you've never graphed the sine function, the cosine function, or the logistics function before. And I put a C by all of those. If you're asked to graph these functions, it'll be on a calculator. I'll show you how they're graphed later, but just keep in mind the harder ones are on a calculator. Everything else on here you should have seen before. And the types of questions you'll be asked are like, give the domain, let's say, of the square root function. F of x equals the square root of x. So you should know what shape the square root function is, and since it starts at 0 and only goes to the right, its domain is 0 to infinity. But if you were asked to give the domain of, let's say, the cosine function, even if you hadn't graphed it by hand before, since it goes to the right and it goes to the left forever, this function has a domain that's all real numbers, negative infinity to infinity. I have all of the notes for every single function as a PDF online. It's called 12 Basic Functions, and it's on the same page as these video notes. You don't have to copy them all down, but if you have questions about some of the answers for these, you can look it up on there. For each basic function, you're going to have to be able to answer the questions on the left. Let's start off with the easy example, f of x equals x squared. All of you should know what a basic parabola looks like. You shouldn't have to plot points to make this graph. So its domain is from negative infinity to infinity. Its range is from 0 to infinity. It's a continuous function. It increases right here. So it's increasing from 0 to infinity. It's decreasing along this section right here, so it's decreasing from negative infinity to 0. This graph is symmetric to the y-axis, so it's an even function. This function is bounded below. It has a minimum, extremes or minimums or maximums. It has a minimum at 0, 0. This particular function doesn't have a horizontal or a vertical asymptote, but on this function, as we head to the right, it goes up, and as we head to the left, it also goes up. So I would say that the limit as x goes to positive or negative infinity of the function is infinity. So in this section, you're going to be expected to make graphs of all of the 12 basic functions and answer these questions about them. Now, I'm not going to make a video that answers every question for every 12 functions. We'll just do a couple of examples. But like I said, there's a PDF that has all the notes if you're not sure about one of them. We'll do one more example of a basic function, but remember, I have the notes for all of the basic functions if you need help with them on a PDF that you can look up on the same page. So let's look at the absolute value function. The absolute value function is V-shaped. Its domain is negative infinity to infinity. Its range is 0 to infinity, and it includes 0, so this has to be a hard bracket. It is continuous. It is increasing right here, so it increases from 0 to infinity, it's decreasing right here from negative infinity to 0. So decreasing is like walking down the hill, increasing is like walking up the hill. Decreasing is a negative slope, increasing is a positive slope. This graph is symmetric to the y-axis, so it's an even function. This is bounded below. It has a minimum at 0, 0. It has no horizontal asymptote, no vertical asymptote, and the limit as x goes to the right or the left, so positive or negative infinity of the function is infinity. This means on both sides it goes up. Okay. Y equals e to the x is one of the graphs you'll expect it to be able to do without a calculator, even though e is kind of an odd number and doesn't, not a nice thing like taking 2 to the third power. You should know that if you take e to the 0 power, you get 1, because anything to the 0 power is 1. And since e is a positive number, if you take it to a big power, like if you took 2.7 to the 5th power, you would get a huge number. And if you took 2.7, let's say, to the negative 5th power, it would become 1 over a huge number, which is very close to 0. So even without being able to plot exact points, you should be able to go, oh, well, anything to the 0 power is 1. Here it's going to get close to 0, and then it's going to get really big. So this should be a basic graph that you can make without the assistance of a calculator. After you make the graph, you have to answer all the questions. The domain is from negative infinity to infinity. The range does not include 0, but goes to infinity. This graph is continuous. It doesn't decrease at all. It just is an increasing function. It's only going up. It has no symmetry, and so it's neither even nor odd. This function is bounded below. It has no max or min. It has no vertical asymptote. It does have a horizontal asymptote at y equals 0. That's right here where it's approaching 0. And the end behavior is written in limit notation. The limit as x goes to infinity of the function. So you can think of this part right here where it says x goes to infinity as saying as you're looking to the right, the function goes up. So that's positive infinity. So as it goes right, it goes up. And the other limit notation, limit f of x, as x goes to the left, so this piece of the function gets closer to 0. So as x approaches negative infinity, the function approaches 0. Okay, one of the functions that you're going to encounter in this chapter is changing an absolute value into a piecewise function, and I wanted to give an example of that. So let's take y equals the absolute value of x minus 2 plus 1. And this graph is shifted to the right 2. And you should know your shifting rules from Algebra 2 last year. If you don't, you can come in and see me after school. It's also shifted up 1. And so I'm going to go right 2, up 1. And then I'm going to draw the graph in. This one has a slope of 1. And you should still be able to answer all those types of questions like bounded or unbounded or continuous, that kind of thing, domain range. Although for this problem, it's important to point out that this is not an even function because it's not symmetric. So even though the base function is even, this graph is not symmetric to the y-axis. And I wanted to do the test with a number this time. So let's say you had f of 2. That would be the absolute value of 2 minus 2 plus 1, which would be 1. If I put in the opposite, f of negative 2, that would be the absolute value of negative 2 minus 2 plus 1, which is 5. Since these two numbers are not the same, this is not an even function. So sometimes students think, oh, well, the absolute value function is even. That's true. The base function's even. But this shifting of it is not. Now, in your textbook, you'll be asked to change this problem into a piecewise function. So the piecewise function is going to be broken up into the part that's increasing. So it's increasing right here, and the part that's decreasing. So the blue part has a slope of 1, so it's y equals 1x, and if you were to extend the blue part down, it would cross the y-axis at -1, so it's x minus 1. And the red part is given by the equation y equals -x plus 3. The blue equation is true for all values of x to the right of 2, and the red equation is true for all values of x to the left of 2. It doesn't matter right here which one you make greater than or less than and which one's just greater than. They just can't both be equal. And so this is an example of where I took an absolute value function, I split it into two separate lines, and wrote it as what's called a piecewise function. You covered piecewise functions in Algebra 2 last year. It might have been a while. Again, if you're not remembering your Algebra 2 very well, come in for help at Access or before school. Okay, on the left-hand side of your screen, you see a table of values for the sine function. The x values are measured in degrees, and the y values is measured in units. If you go ahead and type in on your calculator y equals sine x, and then change your window so that x goes from -90 to 360, and also make sure you hit your mode button and verify your calculator is in degree mode. You should be able to come up with this graph no problem. At 0, the sine is 0. At 30 degrees, it's a half. At 60 degrees, it's 0.8. At 90 degrees, it's 1. And then it comes back down 0.86 and a half and hits the axis. At 180 degrees, it's 0. And then at 270 degrees, it's -1. And I'm going to run out of room, but it comes back up to +1 when it gets to 360 degrees. So the sine function, the periodic function, looks like this. And actually all wave functions can be drawn by sines or cosines. But for you, you should be able to answer questions about the boundedness by looking at the shape of the graph. So its domain goes from -infinity to infinity. It's bounded above. It's bounded below. We don't have to worry about asymptotes or end behavior. You just have to be able to answer questions about what's the basic shape of the graph and the first part of the list.